In this video, I'd like to discuss layering multiple pyro simulations onto particles that are being generated by a rigid body simulation. Now this project I have here is already done and laid out, and I'm quite frankly not a big fan of video tutorials that describe a project that's already been laid out, but this is a fairly deep project and I don't want to take too much time with it or split it into multiple parts. So I'm going to attempt to do a walkthrough as opposed to building from scratch, and hopefully everybody will still find it useful. Again, this is a similar project to what we had done in class. So I'm going to break this down. So first of all, let's just see what I have here. So if I play the simulation, we have a fracture that then generates particles, and then those particles generate pyro. So if I break it down here, I'm going to turn off my pyro sims and I'm going to turn off my particles. So what I've started with is just a basic rigid body Voronoi fracture, which is over here in the rigid sim. So I have my torus object. If I double click on that, we can see that I have the torus, and then I added a surface scatter, and then I did a Voronoi fracture. And then I generated, and all of this, by the way, all of these are done with shelf tools. None of this is customized, or by scratch, I should say. So once I laid out this Voronoi fracture, I went to the rigid body shelf and I created an RBD object. And then that generated the DOP network here, which is bringing in the torus. And I've also added a ground plane, which we can get from the collision shelf right here, the ground plane. So there's a ground plane, the rigid body torus fracture, and that gives us the first layer of our simulation right here. And up here is my ground plane, which I have its visibility turned off. So I can turn it on or off. Now the reason I have the ground plane in its own network window here is because I'm actually using it in all of the simulations. So instead of generating a new ground plane for every simulation, I am reusing it across all of these. So I started by generating it for the rigid simulation. Now, furthermore, the rigid simulation is cached. So again, if I go back into the torus object, I'll zoom in on this a little bit here. I have the simulation cache. So here's the rest node, the assemble node, and the DOP import. These were all auto-generated when we created the rigid body object here. And then what I did is I created a file cache. Now my file cache is set to here. I set up a custom path, so I'm referencing by my HIP file. So again, this whole project is also done in a traditional Houdini project structure. So if I go to the file menu and do new project, that's how I set it up. And then inside there, I reference by the HIP file. That's the $HIP. It's in a subfolder called Geo, and then another subfolder that I created called Rigid Sim, and then the actual name of the simulation cache. So I called it Rigid Sim dot $frame. That's the frame number. .bgo.sc. So you can do that by just clicking on the little browse button here, and I can go, let me bring this over a little bit here. I can go reference by HIP, that's what I had done, and then I went into the Geo folder, and then I hit the new folder button to create a new folder, and that's this one, Rigid Sim, and then I gave it a name down here. And the name I gave it was what I mentioned over here. It's rigid sim dot $F, because it needs to have the frame number attached to it, and then the file extension, which is .bgo.sc. And then you can hit accept, and then you can save to disk to cache that out. And then once that's cached, we check the load from disk button so that it's pulling from the disk and it's no longer looking to the simulation. And then if we don't add a time shift, whatever our file caches, whatever frame our file cache is going out to, it'll generate a warning past that frame number. So my simulation the fracture simulation in this case is everything comes to a rest right around frame 162. So I set it, I changed it here. Instead of going 1 to my entire timeline, I clicked on the start end so that I could see the strings here, you know, the expression. So it's going from the start frame, $F start, and by default it goes to $F end, which in this case would be 240. But what I did is I clicked on this here so that I could see that expression. I deleted it and just hard coded in the number 162. So then that way when I hit save to disk, I'm only caching out to frame 162 and nothing beyond that. So the error that comes up is if I go beyond frame 162, Houdini doesn't know what to do. So it creates an error, or generates an error and says, I don't know what to do past 162 because I don't have any more file cache, even though now my timeline is going beyond 162. So that's what we can remedy that with a time shift. We don't need it. It's not really going to affect performance, but it just keeps it from generating an annoying little red error sign. So with the time shift here, I set it, again, this one is also set to FN or $F start and $F end. If we click on the little start end frame, I can hard code in the value 162. And that's what I did here. I also set the clamp to last. So basically what my time shift is telling Houdini is, hey, when we get to frame 162, just freeze there. Whatever you see in the cache, just keep on that frame as we go past frame 162. So that alleviates that error. And then the last thing that I did is I just, for best practices, added an out null called out rigid sim, because I'll use that to reference the cached file into other networks that we create. So that's step one. So if I come back up here to my object network, the next step is to take the rigid sim and generate our debris source. We want to generate the particles, which I'll turn those on right here. We want to generate the particles that come off of the fracture. I'll zoom in on this a little bit. So again, I used a shelf tool to do this. So what I did is I selected the torus object, and then I came up here to the rigid body shelf, and I used the debris shelf tool. And the debris shelf tool will generate these three nodes that we're seeing right here. So the first one is the debris source. So this is going to be the geometry node that pulls in the cached file from my torus object. So if I double click on the debris source, we can see in here that we have, now it generated a little bit of smoke because this is the Pyro sim starting to generate here, which is a few steps down that I'll get to in a few minutes. So here I'm bringing in my object. It's just an object merge, and it is merging, as we can see here, the node, the out null from my torus object. So that's at the bottom underneath the file cache. Now, when you generate the debris using the debris shelf tool, you're probably going to find an error here. I'm going to move these out of the way because this is, well, actually right here. This is all part of the Pyro sim, which comes next. So I'll move that out of the way and zoom in on this. So once you hit your debris source button, you'll end up with these nodes, but you'll probably have errors here. And that is because of the trail node. So by default, the trail and the debris source will be flip-flopped. The debris source will come second, the trail node will be first. I have another video that I believe discusses this. And what we need to do is we need to flip-flop these. So the trail node needs to come here, needs to be second, and the debris source needs to be first. The trail node is generating velocity. And again, by default, when you click on the debris shelf tool, it wants to generate the velocity first, then generate the debris source. And we get some errors on that because it doesn't, for some reason, understand how to generate velocity on the cached rigid sim. So we can just flip-flop those, because ultimately we want our pyro smoke, or I'm sorry, not our pyro, I'm getting ahead of myself here. We want our particles to inherit some velocity from the movement of the fractured object. So what I did is I just rearranged these. So I put the debris source first, then the trail node, because then that means the trail node will now be generating its velocity off of the debris source. And if I put my display flag on the debris source, we can see what that is. It's the little particles that are just on the edge of the object. See them following the object there. So that debris shelf tool does for the most part, actually gives us this very special node, the debris source node. And what that does is this node is constantly looking at this search radius. And when that search radius goes beyond 0.1, it generates the particles on the edge. So basically it's looking for the fracture, and when the fracture occurs, it generates these particles. Then what we can do is use these particles to generate the other particles that are actually flying off of the fracture. And then we're computing our velocity off of the debris source particles, which means then we can still get the secondary particles that are flying away here. We can get those to inherit a little bit of velocity of the fracture object. So when we come in here, basically we just need to rearrange these. It needs to be debris source, then compute velocity, and then we have the out node. Now another thing that I did here with the with the debris source is I increased its lifespan. It's set to 10 seconds. By default it's set to 1. And then these will disappear after 1 second. Now the reason I increased the lifespan to 10 is because I want these edge particles to stay there longer, because I'm going to create a second pyro source where I'm sourcing pyro off of those particles. Then that way we get 2 layers of pyro simulation. We get some dust that comes off of these small particles, and then we also can get some dust that looks like it's coming off of the fractured object itself. So we're kind of reusing the debris source particles for 2 things. We're using it to generate the small debris particles, and we're also going to use it to generate some pyro. So I can demonstrate that by coming back up to the object level, and I'm going to turn on my pyro sources. So here's my 2 pyro sims. Here's the first pyro sim and the second. The first pyro sim is for the particles, these little particles that are being pushed out here. So if I turn on the pyro import there, we can see those. And let me zoom out from those a little bit so you can see what they look like. So they are following, or that pyro, I should say, is being generated from the little particles. So we can see how it sort of works its way out with them. And then the second pyro source here is being generated from those particles that are on the edge. And I call them the static particles. So if I turn this one off and turn this one on, we can see what contribution these give to the simulation. So they're more poofy and kind of go up in the air more, because I want that to look like dust that's being generated from the large pieces of the original Voronoi fracture. And then when we put both of those together, we get a nice mix between the two. It gives us sort of 2 different directions to our pyro. We have the large debris with more billowy smoke pointing upward or going upward, and the particles that are being thrown out, their pyro has a little more of an outward horizontal movement, and the 2 together work nicely. So I'm going to come back and break this down some more. So we started in the debris source here, which is where we generate the debris source, compute the trail. That creates the edge particles. Then this is being fed into the particle. I'm going to zoom in on these now. That's being fed into the particle simulation here. So we go debris source into the debris sim. So I'll double click on that in here, and we can see that that's being brought in right here on the pop source 1. I'm going into the debris source out. That's where it's pulling from. Now a couple things that I changed in here. Because what you'll probably find is when you click on your debris shelf button, and then you come over here, and in the debris source, when you flip-flop the debris source and the compute velocity, if you rerun your simulation, you'll probably find those particles, these little particles here, will blast away almost uncontrollably. So what I did to control that here in the pop DOP network is that I first of all came to my pop drag node. These are all generated by default with the shelf tool. I came into my pop drag node and I increased the air resistance. That should slow them down quite a bit. And then I also went to the pop source and I went to the attribute tab here and I lowered the inherited velocity. See, it's inheriting the velocity, and that's coming from that compute trail node. And it's just, I think by default mine was 0.56, and that just made the particles crazy. So I dropped that down to 0.2. So between dropping the inherited velocity to 0.2 and adding more air resistance in our pop drag, that allowed my particles, let me turn off my pyro here again for both of these. That allowed my particles, or made my particles more manageable. They feel like they have more weight, they fall to the ground and just slide. Now you probably also find that your particles are not sliding across the ground, they're going right through the ground plane. So the other thing we have to do with our particle simulation here is we need to bring in our ground plane nodes right there. Again, this is covered in a previous video. But the way we do that, just very quickly, is I can come over here to my rigid sim, the rigid sim DOP network, and I can just select the ground plane, the merge, and the static solver and copy them. Then I can come over to my particle simulation and paste them. And then I just connect the pop solver and the static solver with the merge node. And then that gets my ground plane in here, and my particles will now interact with the ground. Now, another thing that you might want to consider is, again, covered in another video, when you generate particles, really with any of your particle tools, but in particular, we're using the debris shelf tool, which creates a particle sim. When we generate that particle simulation, our ground plane is not masked out of this simulation, which can be a little bit of a problem. And what I mean by that is if I come back to my rigid sim, as an example, if I go into, so just to recap what's happening here, we have our Voronoi fracture. It's pushed into the DOP network. We process the rigid fracture, then it's sent back to the torus object. So if I go into the torus object, I'm going to come up here a little bit. It's brought back in right here with the DOP import. Now in the DOP import, we see it says here what network it's coming from, but then more importantly, it says what the object mask is. It's saying, what do I want from that network? Well, if I open this up a little bit more, it's saying that it only wants the results of the torus object. That means it will exclude the ground plane. And that's how it should be set up. Now, when we create a pop network, a particle network, our object mask is actually set to include all, which is just the asterisk. So what I usually do is I come in here and I copy this, Control C to copy, and then I go over to my pop network right here, which in this case is called debris sim. And in here, oh, I'm sorry. I have to go to the node where I'm displaying the debris. So to summarize the flow here, we're bringing on our debris source here, which is the rigid sim. Then we're putting it into the DOP network to process it, and then it's being displayed here. Now I have this display flag off, and I'll talk about that in a minute also. But if I go into this debris node, geometry node, and I'm just going to come right here to the top. There's my DOP import. So that's bringing in the particles. Now, typically, what you'll probably see in here is something like that, where it says object mask, everything. Well, the problem with that is in my particle simulation network, we just put in the ground plane. So that means a ground plane is going to come in here also, and we don't want that. So what we need to do is manually put in what we want from the particle simulation network. So what that would be is, actually, I'm going to pin this so that I keep it here, and I'm going to come back up to the object level just so I can get these names right. So I'm going to go inside my particle simulation network, and my path here needs to be the name of the simulation, so it's debris_sim. So I'm going to replace that right here. Debris_sim. Make sure that's spelled right. If you're on the right track, it will give you a little drop down that says, do you want to use this? So that's good. So I've got that debris sim. And then what object do I want to mask to in here? I don't want the ground plane. What I want is the pop object 1 right there. So I'm going to replace the copied text here, which was the torus object. I'm going to replace that with pop object 1. There we go. So now I will mask that properly when I bring it back into the DOP import, and I won't get the ground plane. For some reason, we have to do that with pop networks. So again, I talked about that in another video, and so I'm just recapping that here again. So I'll come back up to the top level. So again, just to recap where we are, we generated our Voronoi fracture, we processed it, we sent it back to the display node, the geometry node where our display node is. I cached it. Then that cache is going into the debris source, and in the debris source, which we generated this with the debris shelf tool, I am generating the particles on the edge, and then I'm computing their trail, and then that gets pushed into the debris sim network, and then that's pushed back out to the debris node, and this is where we would display it. And in here is where I added that mask that we didn't have. That's right there on the DOP import. And then what I did is I did another file cache to cache this set of particles. Much like the one I did for the rigid sim, I set up a subfolder called debris particles, and then I named it debris particles dot frame number dot file extension. And then I cached it. I also cached this to 162 frames, save to disk, and then load from disk. And I also added my time shift that clamps to the last frame of the cache, which is 162. Now, I mentioned a few minutes ago that I have the display flag turned off for this. The reason for that is because this simulation I'm using for two things visually. I'm using it to generate pyro, and I'm also using it to see these little particles. I want these small particles to be visually littler debris sources in the simulation, as we see here. Yeah, so I add an additional level of debris. So that presents a little bit of a challenge, because if we take this debris source, or I'm sorry, I call this the geometry where we're displaying our particle debris, and we turn that into pyro, which we would do from the PyroFX shelf. I use billowy smoke. If I generate that, these debris sources, the pyro source here, they're always going to have a little cloud around them. And we don't want to see that. Yeah, we want them to generate their pyro and then have the pyro dissipate. But because of the way the pyro shelf tool works, the pyro billowy smoke shelf tool, the way that works, if I double click on this, we'll see it here. And right there it is. See, the little billowy pieces come up now when I jump into this node. You'll see that it's right here, my pyro source, right there. So it creates these little, they look like kind of cotton balls. And I don't want that. And that's, we can't really get rid of that unless we turn the visibility of this off. So that's what I did. So basically what I did here is I took my cached particles in here, and then I generated billowy smoke from them. And then that created this pyro network. So that gives me these, or this smoke result right there. Not by default. If you generate yours now, yours is going to look a little different. We might need to change a few things in the pyro simulation, which I'll talk about in a few minutes. What I want to do, what I want to still focus on here is how I addressed our little cotton balls that are on the particles that were generated here. So again, if we take this node, our particles, our cached particles, and we create billowy smoke, it's going to create the pyro. But what happens in here when we generate that pyro is it creates the pyro source, the attribute noise, the rasterize, and the out. So the pyro source is generating two pyro attributes, density and temperature. Again, this is covered in another video. But what happens is it maintains these little poofs of smoke because it's really basically volumizing the source, in this case, the particles. And so that little puff of smoke will stay there. I mean, I guess we could remove it by animating out our scale here, but then that's going to affect the whole simulation downstream, and I don't want to really do that. So what I found that is an easier or a kind of a straightforward method for eliminating these little poofs is to basically just take this debris, cached debris, and duplicate it. And that's what's over here. See, I put this one in a network called Particles to Display. So in this network, if I double click on this one is not generating any pyro. This one is just the cached particles. So what that allows me to do is display the particles from here, but I still have exactly the same thing here, the cached particles. This one's display flag isn't on, but this is the one that's being used to generate the pyro. So I generate the pyro from it, and the pyro's display is on, but the particles are turned off. So then I eliminate the little cotton balls. See, there's the cotton balls, and notice if I scroll down the timeline, they just don't go away, and we don't want that. But if I turn this off, they're gone. But the information that they fed into the pyro network still exists right there. So I hope that makes sense, what I did there. And just to demonstrate this a little further, if I turn this display flag off, you can see that's the particles right there. So this is displaying the particles. This is generating the pyro. These are identical. They're both the same cached particles. This one is just turned off, generating pyro. That one's actually displaying the particles. So back to where we were. So we take this debris source, we generate our billowy smoke. It's going to create these two nodes. And it's probably going to be a fairly unwieldy pyro sim. So what I'm going to do is come in here and make some edits. So if I go into the pyrosims.network, the main things that I changed in here, now I also added the ground plane. So I copied the ground plane from my rigid body DOP network. I put that in here, just like I did with the particles, so that the pyro interacts with the ground. So that's in here. That's one thing. But the other thing I did, a couple other things, I went to the gas resize fluid dynamic. That's our volume. And in the max bounds, I turned off clamp to maximum so that the particles don't ever hit the edge and become clamped. And some other things that I did here, I went into the Pyro solver and I lowered the buoyancy lift. So these particles, I want these particles movement to be outward more than up. So I lowered the buoyancy lift in order to do that. I also came into the shape tab and increased the dissipation. Otherwise, they'll just stick around for too long. And they're supposed to be more like dust, and dust well, depending on the kind of dust it is and the debris, it could be thick, but in this case, I wanted it to be maybe a little more wispy. So I increased the dissipation. And that's only one of many parameters that we could use to adjust our Pyro sim. And then the last thing that I did in here is I came into my source volume and I animated the density scale. We can see right here, the density scale is set to 0.1, which is giving me the density that I'm seeing here. And then right at frame 74, I key it to be 0. So it stays at 0.1 up to frame 72. And then 2 frames later, I keyed it so that it's 0. Because otherwise the pyro will just keep generating. And I don't want that. I want it to fade away. So this is an easy way to get your pyro to fade away, is by animating the density scale value. At some point, bring it down to 0, and then your pyro will fade away. And that's what's happening here. So that's how I achieved that. And then that took care of this simulation for the most part. And then that simulation here is being fed into its display geometry node, which is this one. It says Pyro Import. So if I go in, we can see if I turn it on and off, there it is. So if I double click to go into this geometry network to see what's in there, what you should have is just the .io and the .import. Now what I did is I added a file cache again. So I cached this out. That's why I'm able to go back and forth in my viewport like this, just scrub it and scrub it. It's because I have these cached already. So same procedure. I added a file cache and I saved it to another subdirectory called Pyro1, and then I named it Pyro1 $F for frame number file extension, which is bgeo.sc. Now with this simulation, I'm running it through the whole timeline, 1 to 240, because the smoke takes a little while to dissipate. And it looks like it's almost gone right around frame 180, so I guess I could have cropped this to 180, but I just ran the whole timeline. And I did save to disk, and once it's done caching, I did load from disk. So then that's the first Pyro simulation done, cached, and in place. So now let's take a look at our second Pyro simulation, which is this one. I'll turn the first Pyro off, turn the second Pyro on. And this one is the pyro that's being generated from those static particles that are right on the edge of the geometry of the rigid sim. So actually where I'm pulling these particles from is the debris source right here, which was generated when we did use the debris shelf tool to make the particles. So just to go back into this node to see what's in there, this is what we had. And then when we select this node to generate another billowy smoke pyro effect, it's going to create these additional nodes that we see here, which we should be familiar with. You know, that's creates my pyro source, and it's sourcing again density and temperature. Then it adds the attribute noise, the rasterize, and then the out. So this is being generated from those little white particles we see right on the edge. So this is giving me some dust or smoke that looks like it's coming off of the large fracture pieces. So again, that is, in order to do that, we come back and select the debris source, then do billowy smoke from the PyroFX shelf. And then that will generate these two nodes here. Now, I don't have to do a secondary particles to display for this pyro system because I'm not displaying the source particles anyway. You know, their display flag is off by default. If I turn it on, we can see they also then would have that little cotton ballish look to them, but we don't need to see them. They're there just to generate the debris particles and also now generate the second pyro sim. So same thing in here. I changed some attributes in the pyro sim. So if I double click to go in there, In my gas resized fluid dynamic, I also turned off the clamp to maximum. And in the Pyro solver, I made a few changes here. This one has a higher buoyancy lift because I wanted the particles to go more up in the air. So I increased the buoyancy lift. In the shape tab, I have a little bit lower dissipation value than what I did for the first Pyro sim. So those are the only things I changed in there. Now in the source volume, I did the same thing here. I animated scale because I want the Pyro to stop generating so that it can dissipate away. So that was the other thing I changed in here. But I think those are the main parameters that I adjusted in this second Pyro sim. And then that gives me this result. So if I go into the Pyro import where the DOP network is sending it, same thing here. I have the visualization, the DOP import, and I just cached it out. Cached it out again, all 240 frames to another subfolder called Pyro2, and then pyro2.frame-number.file extension, and then load from disk. And that gives us basically our entire simulation here. So that's what I have here. 2 Pyro sims and a rigid fracture and a debris particle simulation. So just to recap this, I'll let it play through as I recap it. We have our rigid sim here, which is a Voronoi fracture. We cached it. Then we take that cached simulation and generate the debris source, which is done with the debris shelf button. That generates these nodes. I'll stop this. It's distracting me. So that generates these nodes. Now I duplicated the debris node so that I could use one to generate Pyro and turn the visibility off, and one to keep to actually display the particles. They both are cached particles. They're pulling from the same cache actually for the debris source. And then I took this debris source, or the cached particles, I should say, and generated this Pyro simulation here. And then I took the debris source particles and generated the second Pyro sim. And that gives us this result. So I hope that's still beneficial since I didn't build it from scratch, but this ended up being quite a long video just to simply explain it after it was already created. So I hope that helps, and I hopefully over the next week or so we'll be able to put together some videos talking about how we can render this. I'd like to maybe put one together to show how we could render it with Mantra, and then also one for rendering with Octane. So stay tuned for those at some point. Thanks.